Welcome, everybody. It's a great pleasure to welcome Sam Tilsen from Cornell University here. And I'm talking on behalf of the Speech Prosody Special Interest Group from ISCA and from the University of Campinas. And Sam works mostly in cognitive science and speech planning, and his research interests also included the control speech predictions and the forces which govern change in phonological structure over time. His main interests are on experimental phonetics, laboratory phonology, speech articulation, speech planning, syntax-semantic interface, and so on. It's a very great pleasure to have you here, Sam. The floor is with you. Thank you so much.
Okay. First off, I'd like to thank the organizer, Plinio, for giving me the opportunity to give this talk. I want to start with an observation, which is that in conversation, speech is intermittent. What I'm showing you in this figure are some randomly selected turns from the switchboard corpus, where fluent speech is shown with the gray bars, unfilled pauses in white, and filled pauses in yellow. And as you can see from this representation, there's kind of a fair amount of irregularity in the timing of the speech that's produced. Now, what do I mean by intermittency? Why don't we listen to the sound of a fire crackling? And I want you to pay attention to the temporal intervals between successive crackles. What you might have noticed about this is that there are a lot of very short intervals between successive crackles, but occasionally there are longer intervals and very rarely very long intervals. And this sort of irregularity is at least descriptively one of the things that we mean by intermittency. You can think of intermittency as an irregular reoccurrence of events or an irregular alternation between states, where irregularity implies aperiodicity. There are a lot of physical, biological, and man-made systems that exhibit this sort of temporal intermittency. These are all very complex systems. Intermittency can also arise in very simple systems like the three-dimensional Lorentz system. So if you take the sign of the x-coordinate of the state of the Lorentz oscillator as its state and plot the distributions of durations of time that it spends in that positive or negative state, what you notice is that it's a logarithmic distribution. So there are very many short periods of time in which it's occupying one of the two states and relatively few longer periods of time. And of course, speech isn't low dimensional like this, but intermittency occurs in very high dimensional systems. So fluid flows, for example, under certain parameters can exhibit intermittent bursts of turbulence or chaotic flow. Avalanches are another example. So the periods of time between avalanches and their sizes both exhibit power law distributions. Small ones are quite common, very large ones are quite rare. Excuse me. There's been some interesting work done by a complexity theorist named Per Bach studying avalanche-like dynamics with simple models of sand piles. What happens in these models is that sand grains are periodically dropped on the pile, which will build up till it reaches a critical slope where avalanches become quite likely. And then an avalanche occurs, and with continued addition of grains, the pile builds up again, and then another avalanche occurs, and so on. And one of the interesting things about this model is that the durations of the avalanches, their sizes in a sense, follow a power law distribution. So like the crackling noise I was referring to earlier, there are lots of very small avalanches and occasionally very large ones. Now, the point I'm trying to make here is simply that there are lots of ways for systems to exhibit intermittency. And the question that I'm primarily interested in here is, why is speech activity intermittent? My plan for the talk is the following. I want to consider two possible explanations for intermittency, which I'm ultimately going to reject. One being that perhaps hierarchical prosodic phrase structure is responsible for it. The other being that maybe there's some sort of phrasal rhythm governing production that's involved. And then after I consider those explanations, I'm going to discuss my thoughts on the mechanisms that are responsible for temporal patterns on the phrasal timescale, including phrase final lengthening and the intermittency that I'm referring to. So let's start off thinking about hierarchical prosodic structure. Is this structure potentially responsible for the intermittency that we're observing in conversational speech? As I'm sure you're aware, there are many different hypotheses regarding the nature of the categories that comprise prosodic phrase structure, as well as whether or not those categories can be recursively embedded. We might add to these simpler hypotheses, such as a flat structure or no structure whatsoever. Now, I want to be very clear that when I'm talking about hierarchical prosodic phrase structure, I'm referring to structure above the prosodic word. And throughout this talk, I'm going to abbreviate this reference by referring to prosodic phrase structure, or even more simply phrase structure, sometimes just structure. But it should be clear from the context that this is what I'm referring to, structure above the prosodic word. Now, it's worth making a point about our epistemology of prosodic structure, which is that we don't really observe it directly. Not in the way that we observe patterns in acoustic signals relatively directly. Prosodic structure is something that we have to kind of infer to be present to some extent. We're not observing it directly from the signal, okay? And because of this, I think there are two different ontologies of prosodic structure. On the one hand, there are people who I would think of as believers. They believe that the structure is cognitively real and that it plays a role in governing speech production. And on the other hand, there are people more like myself who are skeptics, who interpret this structure more as a construct of our linguistic analyses rather than being something that's actually operative in cognition in governing speech production. We might also take a kind of more postmodernist perspective where we ask whether the vocabularies that are associated with these theories of prosodic structure, and by vocabulary I mean the sets of image schemas, metaphors, and frames that the theories are constructed from, whether these vocabularies help us conceptualize phenomena that we observe more directly, such as intermittency and other sorts of temporal patterns. So a good starting point then is maybe to ask, well, what evidence exists for or against a role of prosodic phrase structure in production? So I did some analyses of the Switchboard NXT corpus. This is an annotated subset of the Switchboard telephone conversation corpus, and there's a subset of this corpus that has Toby annotations as well, which is useful. What I did is I calculated the first order Markov statistics of ad hoc discourse states from this corpus. So in addition to turn, starts, and ends, I have a state of producing a word exclusive with producing a discourse marker, filled pause, or unfilled pause. The other thing I did is I calculated the residual duration of phrase final phones. And I'm calculating this because this is relevant to characterizing phrase final lengthening. These are this is essentially the duration that's left over in the final phone of a phrase after you've factored out speaker identity and phone identity effects. Okay. So what does hierarchical prosodic phrase structure actually predict? So one thing that it probably predicts is that the boundary or phrase type associated with the structure should account for variation in the degree of phrase final lengthening. Larger structural boundaries should be associated with greater degrees of phrase final lengthening. But interestingly, it turns out when I regress this phrase final residual phone duration with predictors like the Toby break index or the Toby phrase type associated with the boundary, these structural predictors account for very little variation in the residual phrase final phone duration. You can see that the R-squared values here are quite low, okay? Now, this could be maybe just because there are many sources of variation, and so there's just so much to account for, and the structural predictors can't do that much work. But what's telling is that when I consider a non-structural predictor, such as the amount of material that comes after a given boundary. You can think of this as like the number of subsequent phrases after a boundary, or the number of words after a boundary. That these non-structural or material predictors actually account for substantially more variance in phrase final lengthening than the structural predictors. And this is surprising if the structural hypotheses are really going to give us anything. That you think that they would account for more variation in phrase final lengthening than predictors that don't have anything to do directly with that structure. So this is one way in which I think we're not finding great evidence for these hierarchical phrase structure analyses of temporal patterns in speech. Another prediction that we might make from structural theories is that consecutive phrasal units should exhibit a negative correlation in size, which would reflect a tendency toward isochronization. And the reason we'd make this prediction is because we observe that tendency toward isochronization at other levels of the prosodic hierarchy. So between nuclei and consonants within rhymes, or between syllables within feet, or between feet within prosodic words. And so we might expect to observe that sort of pattern as well at a higher, longer time scale. Now, the measures of size that I'm looking at here are the number of words in a phrase, number of syllables, and duration of the phrase. And what I find when I do this analysis, which is shown here in the lag1 autocorrelation of these size measures, is that none of them exhibit negative correlations. We're not seeing that negative correlation that we might expect. Instead, we actually see some subtle positive correlations, which I think might be due to interspeaker variation in fluency or the ability to semantically chunk into larger or smaller chunks. So this is another way in which I think predictions that we might make from structural hypotheses aren't really being observed in conversational spontaneous speech. The third prediction that I think we would make is that fluent stretches of speech that are long enough to support this elaborated hierarchical phrase structure should be common, or they shouldn't be uncommon. Now, how long is long enough? Well, I think 1 or 2 words is probably not enough to motivate this elaborated structure. 24 seems like it would be plenty. Let's pick something in the middle and say it's 12 words. Well, it turns out that only 10% of fluent stretches of speech are longer than 12 words. What I'm showing you here is a survival function of fluency as a function of the number of words in a stretch. And it shows us that by the time that in only 10% of the time when you're speaking, does a fluent stretch of speech reach at least 12 words. And that, that's not all that often. It's a direct consequence of the fact that the transition rate from a word to non-word state is about 0.16. So every time I'm producing a word, there's a 16% chance that the next thing I produce won't be a word. Now, what I take from these analyses is that phrase final lengthening and isochronization predictions that we would make aren't really consistent with what we're seeing in the empirical data in the corpus. In terms of the long fluent stretch frequency analysis, this is a little more subjective in its interpretation. Is 10% of the time often enough to motivate the need for this hierarchical prosodic phrase structure? I don't think so, but potentially other people could. Now, there are a couple more indirect forms of evidence that we might bring to bear here. One involves transcriber agreement on the sorts of categories that we might expect transcribers to agree on if these hierarchical prosodic phrase structures were cognitively real. It turns out they tend not to exhibit very high agreement rates on these, even though they've been trained to identify these things like break indices or phrase categories. And so the transcriber agreements that I'm showing here are representative of what you see when people analyze transcriber agreement. And it's kind of surprising that we can't agree more on these sorts of things, or it's surprising if they're cognitively real. The other form of indirect evidence that I might note, which is simply that we have so much theoretical disagreement regarding the nature of the categories themselves. I would think that if these things were really playing a role in speech production, we might have reached some more consensus on the nature of that structure. But really, I think we're all over the place in terms of how we conceptualize the structure and even whether we believe it's real in the first place. So the inference that I'm drawing from all of this is that maybe prosodic phrase structure doesn't govern the production of conversational speech. And it really is just something that we're imposing as analysts after the fact, maybe because it helps us talk about patterns to some extent. One thing that you might notice is what I haven't done here is attempt to assess predictions of hierarchical phrase structure theories that relate to the timing of phrasal initiation, the patterns of intermittency that I'm observing. And that's because it's entirely unclear what these theories actually predict about phrasal timing. They don't have the linking hypotheses, or to my knowledge, they don't have the linking hypotheses that would really allow us to generate predictions that we could assess regarding timing of phrasal initiation. At this point, you may be saying, well, okay, but what about all the laboratory studies that support this hypothesized structure, right? Don't those prove that this structure is real? And I think the answer to this is really no, they don't. And the reason for this is that I think that there are some problems with the argumentation that is used in these sorts of studies. And I'm not going to pick on any particular study. What I'm going to do instead is describe what I consider to be a workflow for fallacious argumentation for prosodic structure that I think is common to all of the studies that have argued for it in this way. So this workflow starts by assuming some structural analysis of utterances, and then designing experimental conditions to distinguish those structural effects, subsequently conducting analyses that find correlations between those hypothesized conditions into the phonetic measures that are associated with those conditions. And from that, inferring that it's the structure that caused the correlation, that it's the structure that was playing a role in driving and producing the correlation. There are a number of issues with this, though. One issue is there's some circularity here. Notice that the analysis and the design of the experiment are assuming the existence of the structure in the first place. So they're not discovering the structure, they're assuming it exists and observing that it correlates with some phonetic measures. The second issue is that we tend to overinterpret the statistical results of these sorts of studies. It's one thing to find that the two population means are statistically significantly different, but very often it's the case that the distributions of measures associated with those conditions overlap to a great degree. And we tend to underplay that degree of overlap. One wonders why there would be so much overlap in phonetic measures associated with hypothesized conditions if those conditions are really playing a large role in production. And then, of course, I think the third issue, maybe the most obvious one, is that correlations don't entail causations. And whenever we make this invalid or fallacious inference, what we're really doing is showing a lack of imagination. There can always be other explanations for correlations between the things that we've hypothesized to exist and things that we measure that don't have anything to do with our hypothesized entities. And so if we can think of other ways to account for these correlations that don't involve those hypothesized constructs, we really shouldn't be drawing these strong inferences about causation. Now, a more compelling workflow that I think we could pursue to discover prosodic structure, if it exists, would use unsupervised learning. We could take speech data and we could train unsupervised learning algorithms such as autoencoders to develop representations and hidden layers that maybe would correlate with our structural hypotheses. To my knowledge, no one has attempted this, and I'm not doing this here in this talk as well, but this at least would get around the issue of circularity in terms of not needing to assume the hypotheses in the first place. So at this point, even though I'm kind of bearish on the reality, cognitive reality at least, of these hierarchical prosodic structures, I want to emphasize that we still need to explain why there would be any correlation whatsoever between these structures and phonetic measurements that we make. And so I'll come back to that later in the talk, so stay tuned for that. What I want to do now is turn to the second potential explanation for intermittency, which is maybe there's some sort of phrasal rhythm or an oscillatory mechanism that governs phrasal timing that's giving rise to intermittency. So is there a phrasal rhythm in speech? And I want to be very clear that when I'm talking about phrasal rhythm, I mean rhythm on timescales that relate to this hierarchical prosodic phrase structure that's above the prosodic word that I'm focused on in this talk. I'm not referring to metrical rhythm, where I have very different ideas about the mechanisms that are involved in causing rhythmic patterns to arise. So if you're interested in that work, you might check out this paper. But back to phrasal rhythm. Is there a phrasal rhythm in speech? Okay, so what is rhythm in the first place? It can't really be any temporal pattern whatsoever, right? If we allow anything to be a rhythm, then the word becomes meaningless. If you look at various definitions of rhythm and its use in literature, what you'll find is that we usually use rhythm to imply some sort of regularity of a temporal pattern. So this, you'll find the qualifier regular in dictionary definitions. It occurs in linguistic definitions. The empirical studies that assess rhythmicity, at least at the metrical level, have used isochrony as a way of assessing it, at least initially. And for authors who argue against phrasal rhythmicity, that rejection is based upon the absence of regularity. So rhythm really has to imply that there's some regularity to a temporal pattern. But what makes a temporal pattern regular? This is a really tricky question. We can't distinguish between regular and irregular patterns without making some arbitrary decision about what constitutes regularity. So ultimately, whether there's a phrasal rhythm of speech is something that I think is inherently subjective. I'm going to illustrate this point with looking at a specific study that was recently published that argues for phrasal rhythmicity. Okay, so regarding empirical support for regularity in phrasal timing, I think the most compelling evidence that would exist for this regularity would be some sort of periodicity of phrasal initiation or some sort of tendency toward phrasal isocronization. But to my knowledge, I don't really know where the evidence for this is. I haven't seen any good evidence for either of these. In fact, if you think about the lack of the negative correlation between adjacent phrasal units that I showed earlier, that's counter evidence for one aspect of this. There is, however, a somewhat recent study that has argued that there is regularity at the phrasal timescale. This is Inbar et al. 2020, where what they did is they looked at manually labeled intonational units from the Santa Barbara corpus of spoken American English, along with some other corpora. And they used this interesting phase consistency measure that had been developed for studying neural oscillations. What this involves is taking a wideband, in their case, taking a wideband amplitude envelope of the speech signal and splitting it into 2-second windows that are centered on the onsets of each intonational unit. They then apply a Fourier transform to each window and extract the phases of each of the complex Fourier coefficients. Okay, so this phase consistency measure is essentially an average angular distance between those phases for a given frequency component for all of the windows from a speaker, and then they average over speakers. What this tells us intuitively is how similar the phases of a particular Fourier component are across a data set. And if they're more consistent, it suggests that maybe there's more regularity in the rhythm associated with that frequency. What they found is that there's a peak in the phase consistency function of frequency around 1 hertz. And they interpreted this to suggest that speech is organized into prosodic units that give rise to this low frequency rhythm that's around 1 hertz. They state that speakers express their developing ideas at a rate of approximately 1 hertz. So they're suggesting that there's a rhythm of production around this frequency. But I have a number of criticisms of this method that I'm going to lay out at this point. So the first is that they're using 2-second windows of the signal, which entails frequency bin resolution of 0.5 hertz. And this is quite wide in relation to the duration of typical intonational units. So there's not a lot of precision in the resolution of phase consistency across frequency. Secondly, the phase consistency analysis is much more complicated than isochrony or periodicity analysis. And that raises the question of why are there discrepancies between those simpler analyses and the more complex one. Third, the manual labeling of IUs that is involved in their analysis presupposes their existence. This is a form of the circular argumentation that I mentioned earlier. Don't forget that intonational units are hypothetical entities. And also, their analysis is aggregating over speech that's produced at different times, as opposed to looking at temporally local relations between successive intervals, such as what happens in the isochronization analysis. So, on top of these, and perhaps the most severe criticism I have, is that our interpretation of the peaks in these functions is subjective. So they conducted this analysis on 6 languages. In all 6 languages, they're finding some sort of mode or a couple modes near one another around 1 hertz. But I don't think it's enough just to find a mode in a function like this. We have to take into account the width and the shape of these peaks around the mode, not just the presence of a mode itself. Consider that the half bandwidths of these peaks extend from approximately 0.25 to 2 hertz, or 4.0 to 0.5 seconds, which is a fairly broad range. We could actually take this as evidence against temporal regularity. Why aren't the peaks sharper? If there really is this rhythm that's present, then maybe we'd expect the peaks to be sharper instead of so broad. So I'm not all that convinced that this is strong evidence for a phrasal rhythm in speech. And that's important for this talk because if there were, then that might be a really important source of intermittency. But so I think in any case, at least for me, this doesn't argue strongly for rhythmicity, but it's a subjective decision, right? Are these peaks sharp enough to promote rhythmicity? We're going to be faced with the subjectivity of how we interpret, regularity, no matter what we do when we're conducting empirical analyses. I try to take a little different approach to investigating this by, instead of looking at empirical patterns, to ask what sorts of oscillator models can generate patterns that are empirically consistent. So I implemented a very simple model of oscillator-driven phrasal timing, where I merely assumed that the initiation of a phrasal unit, and these are going to be intonational units in this case, is triggered when an oscillator reaches a particular phase. This is a common assumption in oscillator models at other levels of the hierarchy. I have a variable that describes the frequency of the oscillator, which can vary from one cycle to the next. And I use a random variable delta f to determine how much that change is between cycles. Now, one important thing to consider about this is that if we allow this variable delta f to be unbounded, it allows for arbitrary frequency changes, and that just results in an overly powerful model, a model that can generate any pattern of phrasal initiation that we like, because it can change frequency from one cycle to the next, however we like. So I investigated in simulations the consequences of imposing bounds on this delta f variable. I'm modeling the frequency as a random walk, where the step from one cycle to the next is constrained to be in a range, negative delta f max to delta f max, that I'm varying parametrically across simulations, where within simulations I generate thousands of phrasal timing patterns. And I also note that I impose the constraint that the frequency that results from the step of the random walk should fall within a specific bounded range, which I'm taking as the percentile range of the empirical distributions of intonational unit intervals, the time periods between their onsets. So I'm conducting these simulations where I'm varying how much the step of the random walk of the oscillator's frequency can vary from one cycle to the next. And for each of those parameter values that I'm exploring in delta f max, I'm able to calculate an autocorrelation of phrases that the model generates. And it turns out that the value of this parameter that's most consistent with the empirical autocorrelation of intonational units in the Santa Barbara corpus, the English corpus, is about 1.35 hertz. So what that means is that the cycle can decrease or increase by up to 1.35 hertz from one cycle to the next. That frequency can change by that much. And this is a fairly drastic range, right? It's actually 70% of the allowable frequency range itself. And the reason I think this is a bit worrying is for the oscillator model is because it kind of subverts our notion of what an oscillator should be in the first place. If an oscillator can just very powerfully change its frequency from one cycle to the next, that kind of contradicts the notion of what we expect from an oscillation, that just be some consistency from one cycle to the next in terms of frequency. Maybe not identical frequency, but the changes should be smaller. So I don't think that an oscillator model is all that viable as an explanation for the timing patterns that we observe in terms of unit initiation. Now, you might say, well, but what about the brain? We know that there are neural population oscillations at a wide variety of timescales in the brain. And so shouldn't we expect that this would be involved in the production of speech somehow? Okay. It turns out that when you look at the evidence for the involvement of brain rhythms in speech, the vast majority of it relates to perceptual patterns, perceptual phenomena, not production. Moreover, the frequency range that's necessary to account for a hypothetical phrasal oscillation which is about 0.25 to 2 hertz, is probably unlikely to have a single neurogenic origin. What I mean by that is that it's unlikely that there's a single mechanism that gives rise to the oscillation frequencies in that time scale. Just in part of the reason that I say that is because there's disagreement among neuroscientists regarding these ranges themselves and whether or not delta is composed of multiple subbands and what sort of mechanisms give rise to those different types of delta and so on. And then on top of that, it's kind of just puzzling that the strongest delta power that's observed occurs during sleep. You would think that if there's a low frequency oscillation that's involved in speech production, that oscillation wouldn't be the strongest when we're sleeping, but it would be stronger in general when we're awake. So it's for all of these reasons that I'm not really convinced that there's an oscillatory mechanism that governs phrasal timing at this time scale above the prosodic word. Okay. So at this point, we need to ask, well, what gives? What is responsible for the timing patterns that we observe in speech? Now, I want to focus on a couple specific phenomena going forward here. So the first is phrase final lengthening. I think we need an understanding of why phrase final lengthening occurs. And if it's not going to be prosodic structure, we need some other explanation for it. And then related to that is the relation between phrase final lengthening and conceptual grouping. When I say 1 plus 2 times 3, as opposed to 1 plus 2 times 3, my lengthening patterns differ, and they're associated with the different conceptual groupings of those two utterances. And then finally, we need an explanation for intermittency. So I'm going to attempt to address these phenomena right now. Starting with phrase final lengthening, the question is, why does phrase final lengthening correlate with these hypothesized prosodic phrase structures that our theories have hypothesized, if not because that structure plays a role in production? Well, I'm going to try to describe how I think about why we observe phrase final lengthening and the mechanisms that are behind it now. So a lot of my work for a while now has made use of Grossberg's competitive queuing model. This is a model of how we sequence actions. It's a very generic model. It's not specific to speech. But the model works like this. So this is kind of my elaboration of it. Imagine that we have a set of 3 action plans that are comprise a sequence that's going to be produced. Prior to the initiation of that response sequence, the activations that are associated with those plans form a pattern of relative activation that corresponds to the order in which those plans are going to be executed. So that when you go to initiate a response, there's a competition process where the activations of these plans increase until one of them exceeds a selection threshold. That causes the competitors to be gated. They're temporarily prevented from exceeding the threshold, while the motor programs that are associated with the selected plan, the above threshold plan, are executed. Okay. Now, the next thing that happens is ultimately we receive feedback regarding the successful achievement of the targets of those motor programs, and that leads to a suppression of the selected plan, which allows the competition process to resume such that the next most highly active plan will be selected, and ultimately feedback will suppress it. And in that way, all of the plans can be selected and suppressed in an order that corresponds to their initial relative activation gradients. Okay. Now, what I've argued in selection coordination theory is that we can think of these plans as competitively selected sets of co-selected gestures. So each plan is really a set of gestures that are selected together, and they tend to correspond to syllable or moricized units. And a lot of what selection coordination theory is about is how there are developmental changes and how gestures are grouped into these co-selection sets, and how we can understand cross-linguistic differences in phonological typology along these lines. But what I want to emphasize here is the following. Notice that it's feedback that governs the duration of time that one of these actions is selected. Okay. And one of the things we know about feedback these days is that there are actually 2 types of feedback for motor control. On the one hand, there's external sensory feedback. We create information in the environment, acoustic energy, patterns of muscle tension, and we have peripheral sensory organisms that take that information and transmit it back to our central nervous system. So this is an external sensory feedback loop, and it's relatively slow compared to the other type of feedback, which is an internal sensory feedback. So you can think of internal sensory feedback as information that never really leaves the central nervous system, and it's often described as the predicted or anticipated sensory consequences of our current motor state. Okay, and the utility of this sort of feedback is that it's much quicker than external feedback. Now, one of the things that I found recently in an empirical study is that when people are speaking out loud, as opposed to when people are speaking internally without conducting any articulatory movement or creating any acoustic energy, when they're speaking out loud, they tend to speak more slowly than they do when they're speaking internally. And what I've suggested is that this supports the idea that if you're relying solely on internal feedback, that you're not going to speak as slowly as you are when you're relying partly on external feedback. That somehow attending to the external sensory feedback of your speech causes you to slow down. And so this is something I've argued recently, is that we actually learn to use our attention to our own external sensory feedback to slow down our speech. So what you might imagine is that typically if we're producing an utterance, for the beginning of that utterance, we're relying more on internal sensory feedback. And so we're speaking relatively more quickly. But toward the end of the utterance, we tend to rely more, we pay more attention to our external sensory feedback, and that slows us down. So this is a mechanism that I believe is responsible for phrase final lengthening. Moreover, what I've argued is that we can actually learn to use our attention to external sensory feedback to slow down in a subconscious way in order to signal conceptual grouping. So if you think of being asked a question like, who is in the library? The slowdown that occurs at the end of a conceptual grouping like Alan Bow or Cam, that slowdown occurs because we're attending to our feedback more in that location because it corresponds to the end of a conceptual grouping. And if you contrast that with a different conceptual grouping, you get a slowdown in a different place. So what I'm saying is that phrase final lengthening is really some kind of feedback attention effect, okay? Is that we have learned to attend to our own speech at certain times, and that slows us down, okay? So the last thing that I want to do in this talk is to describe my explanation for intermittency. And to do that, I'm going to give a brief introduction to my syntax with oscillators and energy levels model. So this is described in detail in a book that I published a while ago, and it's a very detailed theory that I'm not going to be able to do a lot of justice to here, but I'll try my best because I think that this can give us some insight into why we're observing this irregularity of phrasal timing in speech. So in this theory, there are actually two domains that are modeled in parallel. There's a conceptual syntactic domain and a gesturomotoric domain. And one of the important things about this is that the mechanisms that are responsible for organizing systems in both of these domains are the same. The same mechanisms are operating in both of these domains. Okay. One of those mechanisms is an oscillatory relative phase coupling mechanism. So the systems that become excited in these domains phase couple to each other in particular ways. And I'm not going to be able to get into all the details, but I'll mention that in the conceptual syntactic domain, these phase coupling relations correspond to meaning relations. Whereas in the gesturomotoric domain, they correspond to patterns of articulatory coordination. And so this phase coupling mechanism is playing different functions in the two domains, but the mechanism itself is identical. The other important mechanism that's operating in this theory is a mechanism that organizes these systems in terms of their relative activation or what I call excitation, because it's kind of discretized in this theory. And how this works is just like in the competitive queuing model, prior to initiating a response, the systems become organized in a relative excitation hierarchy, which is shown in a kind of schematic potential function here. And when a response is initiated, these systems are promoted such that one of them will occupy the selection level of the potential. Okay, ultimately feedback, just like in the competitive queuing model, induces the demotion of that selected system, or it could be multiple systems, and the competitors are promoted. And that iterates until all of the systems have been promoted to selection level and demoted. That same organization is happening in the gesturomotoric domain in relation to the systems that are associated with currently selected conceptual systems. Okay, so selecting the conceptual syntactic systems induces this sort of organization in the gesturomotoric domain. Okay, the point of all this is that you can generate activation state trajectories from this way of thinking that are competitive queuing-like and that can account for what's happening at the gesturomotoric level as long as what's happening hypothetically at the conceptual syntactic level. Right? So how does any of this relate to intermittency in speech? Well, there's another mechanism in this theory that effectively plays a role of monitoring the states of all of these systems in each domain. And this is something you could think of as a coherence monitor, okay, or a coherence detecting system. And what it does is it analyzes the relative phase pattern of the systems, which you could think of as quantitatively a degree of cross-spectral coherence of their phases or their phase states, and also the level occupancy pattern, the excitation organization that is involved in this model. And so this system is monitoring, this coherence monitor is monitoring those aspects of the system state continually. And so what's happening in a kind of canonical production. So here I'm showing a simulation of an SVO utterance, and I'm going to use SVO utterances for the entirety of this talk. What you can imagine is that initially the states of the systems that are involved in production are kind of non-coherent. They're kind of a degenerate or incoherent pattern. But over time, quite rapidly usually, there's a cooling process that occurs that allows those systems to achieve a stable pattern of relative excitation. This is kind of a rapid quenched sort of cooling or a rapid annealing. And as a consequence of this, the order of the full system state increases because the fluctuations that are influencing the system, the randomness that's present is decreasing in nature. That's analogous to a temperature decrease. So these systems rapidly become coherent through this rapid Coolidge process. And when the coherence monitor detects that has occurred, it triggers the selection process. And so that allows the competition to occur where the most highly active system can become selected and so on. Okay. I also envision that this coherence monitoring and annealing operates between each epoch in which the systems are selected. Okay, so not only initially, but between these selection epochs, there are also this rapid cooling process in which the coherence monitor is dictating when competition can resume. So let's compare now what happens in a canonical trajectory where things don't really go wrong with what can happen due to the random fluctuations that are present in the system. So one thing that can happen is that noise can cause a degenerate excitation state to emerge where multiple systems occupy the same level, which is a form of degeneracy. And the monitor detects this and effectively restarts the annealing process. The result of this is there's essentially a hesitation, a longer period of time before the utterance can be initiated. Okay, so this corresponds to an utterance initial hesitation of sorts when this happens. The other thing that can happen is it can happen within an utterance, that a degenerate state can arise between selection epochs, and that induces a within utterance hesitation. Okay, so I was interested in how these cooling rates associated with the utterance initial and reorganization cooling processes influence the likelihood of disfluency. And so I conduct simulations where I vary for example, the initial cooling rate and find that there's essentially a Goldilocks zone where disfluencies are relatively unlikely. But if you cool the system too quickly or too slowly, you observe that disfluency rates become very high. So if the system's cooled too slowly or too quickly, what happens is it doesn't have enough time to form a coherent state before production is initiated. And so that a disfluency arises due to degeneracy. But if you cool it too rapidly, if you cool it too slowly, there's too much time for the systems to evolve, and that can lead for them to jump due to random fluctuations to a pattern that's degenerate. So cooling too rapidly or cooling too slowly gives rise to disfluency utterance initially. And effectively, the same thing can happen within an utterance by cooling too rapidly or cooling too slowly. Okay. Another thing that happens in this model is that if you couple concept systems together too strongly, that can lead to higher rates of disfluency. And also that if you excite either too few or too many concepts from the environment, there's an environment that actually excites concepts in this model, that will lead to disfluency as well. Because if you don't have enough concepts that are excited, then you can't achieve a coherent state. If you have too many, they interfere with one another, and that leads to greater likelihood of disfluency. So the takeaway of all of this is really the following. What I'm saying is that I think of it as being something like randomness in the environment and in the processes that are responsible for conceptual syntactic organization that is ultimately responsible for the temporal patterns that we see in terms of the timing of the initiation of phrases, or this intermittency that I'm observing. Okay, and the consequence of this is that we can think of prosodic timing as really kind of an epiphenomenon of the requirement that conceptual and syntactic systems typically have to become coherently organized before we'll produce motor actions. And this is kind of analogous to the process of approaching a critical point in the sand pile model. And you might think of the resulting avalanches or speech activity bursts that occur as varying in size because there may be fewer or more conceptual systems that have become organized in this period of time prior to the initiation of an utterance. Okay, so ultimately, the perspective I'm taking here is one where I'm kind of interested in the question of how we should be talking about the phenomena that we're studying. And what I'm arguing is that I think that in terms of what vocabulary we should be using to talk about these sorts of phenomena, and again, by vocabulary I mean it's the conceptual metaphors and the schemas and frames that we use to construct these vocabularies, that I think we need a more complicated and dynamically oriented vocabulary to really help us understand a lot of the phenomena that we're interested in. And I don't see the structural theories that we have as being well suited to providing that vocabulary. So that's all I have to say. Be eager to hear some questions. Thank you.
Thank you so much, Sam, for this very interesting talk. The exhaustiveness, the richness of phenomena you want to treat with this kind of model is very good. Now we have about 15 minutes for questions, please.
Okay, we haven't received any questions so far, but I'm sure that we'll receive them soon. It's the time for people to write them. Well, in the meantime, I can ask a question.
Yeah.
Thank you very much for your talk, Tilsen. I really like it. I would like to hear a bit from you about a topic that interests me. That is the relation between speech melody and supralaryngeal gestures. Because many studies in phonetics and phonology, states that there is and that there can be observed some kind of temporal relation between supralaryngeal gestures and laryngeal gesture related to epidural production. So my question is, how could this model, this competitive cueing model, right, explain this kind of, coordination between F0 production and supralaryngeal gestures,
Yeah, that's a great question. So I actually have in this theoretical framework an analysis that attempts to account for this for the phenomenon of accentuation, really. And one of the constraints that makes a lot of sense in this framework is that for a given epoch, for a given set of conceptual syntactic systems that's selected, there's at most one accentual system that might be selected with those, which that accentual system would then be associated with gestural systems that could do things like pitch accents or boundary tones or that sort of thing. And so I think that for any given epoch in which we've achieved this coherent state and we've selected some systems that are driving control, there's a potential for some sort of pitch accentuation gesture, but we don't observe them all the time because we use them in association often with specific semantic functions, like things like focus, contrastive focus, or indicating specific emphatic relations. And so as long as these sorts of systems have the ability to interact with whatever it is that represents our intention to to communicate that kind of emphasis, then I think the model can handle that sort of thing. One of the things that that I think is relevant here is if you look at phenomena like post, the kind of the post in pre-focus register compression or suppression of the magnitude of the use of pitch that Simon was talking about in his talk last week, is that it kind of makes sense if these systems are they're organized in this hierarchy, but they're not currently being selected, that they need to remain suppressed to a greater degree than they otherwise would. And so when they do become selected, their effects tend up being weaker. This is kind of the dissimilatory effect that I was trying to describe in my questions with the other week with Simon. And so I do think that there's a great potential for us. I do think that this model really does have a lot to say about how we're using laryngeal control, but some of it might have to do with systems that are specific for things like producing pitch accents, where others might have to do with something that has to do more with the register, the range of F0 that we intend to use in a given epoch, and that's something that's a little different.
Okay, thank you very much for your answer. And now we have received some questions here.
Okay, so Gerard Bailey, what about pauses? The syllable is a good mediator between three oscillatory mechanisms, breathing. See the quantal nature of tendency to see Bailey. Yeah, so what about pauses? Well, pauses for breathing are, these aren't in the model, but most of our pauses in speech, I don't think are pauses for breathing. I think they're pauses, the reason I'm saying, filled pausing or unfilled pausing when I'm responding to these questions is that I'm trying to reach the state where I have some concepts that are excited because everything's bouncing around and this cacophony, and your question has excited lots of things, and I'm trying to achieve some coherent organization that I can translate to that I can then use for a motor production. And so I think that almost all pausing is like this. I mean, we can intentionally, purposefully choose to pause. That's another thing that we can do. But I think a lot of our unintentional pausing is just because the system hasn't reached the right state to induce motor action, and we have these kind of repair strategies where we have this or maybe we kind of know the initial concept that we'll select, but we haven't figured everything out, and so we might kind of repeat an initial articulation several times, a form of stuttering, not the clinical sort, but just kind of initial repetition of an articulation, and so yeah, that's kind of what I think it is going on with pauses. But you're right, they're like breathing pauses are something different, and I'm not sure I'm convinced. I don't know about the role of the syllable in pausing. It feels like we are liable to interrupt ourselves within syllables. I don't know if we interrupt ourselves more or less frequently within or between syllables. We certainly cut off our speech mid-syllable, within articulations that we would say are part, comprises syllables. So it'd be interesting to look at whether cutoffs, I'm sure people have looked at this, but whether or not cutoff frequency is more likely than we would expect otherwise in terms of its occurrence relative to articulations associated with a unit like a syllable or more or something like that. It's an interesting question. Yeah, you have to type a follow-up anyway. So I'll go on to the next question. If you have a follow-up, you can ask that. So Valentine asks, is there any evidence on the fact that rhythm identifies correct and incorrect speech production or even speaker? Yeah, I mean, If by rhythm we mean temporal pattern, not necessarily a regularity, but that a temporal pattern of phrasal initiation or phrasal durations and along with that pausing that's involved, whether we can use that to identify fluent from disfluent speech or just recognize speakers, that makes a lot of sense to me, because I think that, again, what's driving the temporal patterning has a lot to do with how well we're able to, without allowing degenerate states to arise, to form these coherent organizations that we can use to produce speech. And so I would imagine that there is a lot of interspeaker variation in that kind of, fluency or semantic, chunking ability as well. So both the sizes of the organizations that we're able to create, as well as how easily we can create them without leading to incoherent states, has got to be specific not only to the individual, but to the individual's physiological state, right? Like if I had maybe less coffee for this talk, who knows? Maybe I drank too much coffee, and so my cooling processes were too rapid, and I was more disfluent than I would otherwise be. But maybe if I hadn't gotten any sleep and didn't drink any coffee, my cooling processes would be too slow, and I'd be disfluent for a different reason. So I think there's a lot of intra-speaker variation in addition to interspeaker variation. But I wouldn't be surprised if classification algorithms can do a good job in identifying speakers based upon phrasal timing patterns, which I don't consider necessarily regular, but they are timing patterns. Okay, Yu says, are you saying that regularities in tonal patterns have some kind of separate and or at least partially non-overlapping mechanisms of the mechanisms we've been discussing? Not really. I'm trying to say that there are dedicated systems that are intonational in nature, but not tone. So not lexical tone, if you're talking about lexical, but we're talking about intonational tones. That there are special systems that have the property that only one of them can be selected in a given epoch, and that these are associated with patterns of pitch accentuation in boundary tones that arise, but that we can't actually put two pitch accents in the same epoch of selection. I mean, you can have a coordinated system of pitch accents, but you can't have two accentual systems. And so, no, it's not that there's a separate mechanism, but it's just that there are special systems that are involved with this. And I think you're talking about, yeah, I'm hoping that you're talking about like the intonational patterns, not lexical tone patterns. But maybe with lexical tone patterns, those I would think of lexical tones as just like gestural systems in a sense, other than the fact that we can't define their states in a geometric coordinate. For lexical tones, yeah, if you think about like the evidence that there's been a number of studies now that show these lexical tones have these precise coordination patterns that have these subtle but kind of stable displacements of tone gesture initiation relative to consonantal and vocalic gesture initiation. A number of people have found this, that the tone gestures are really just kind of really like articulatory gestures. And so these will be co-selected with oral articulatory gestures at the gestural-motoric level. So if you meant tonal at lexical tone, that's the response. But if you meant, if you were talking about intonational, it's happening with these accentual systems at the conceptual syntactic level.
Please, Sam, there's still another question by Bruce McKee. Do you see?
Yeah, I'll give a quick one to this because I can go downstairs and answer Bruce's question later. But no, I don't think I don't really think you would create I mean, you could create a phase diagram, but really, like, the point is that when you reach the critical point, you don't go. I mean, when you reach the critical point, sure, that's when the action occurs. But you don't really go past the critical point and worry about like further evolution in a different phase. Like the point is reaching that new phase in the first place. So yeah, I mean, you could create a phase diagram, although it's still quite hypothetical exactly how we want to characterize this, what is the origin of this temperature variable that we would vary here. So but sure, yeah. Christine Yu is from UMass, yes.
Okay.
Yeah.
Other questions?
No, I think that's all.
Okay, it's 2 p.m. Thank you so much, Sam. I'm sure if you have some of people from YouTube has questions for later on for some tips, I'm sure you'll be able to reply by using email, no problem. Thank you so much, Sam, for this interesting talk and for presenting several aspects of your comprehensive model. Thank you so much. And I also thank you all the audience that listened to us or to the videos after the day of the presentation. And thank you for your support to the Speech Prosody series of lectures. And see you on the next conference lecture that will be given by Gerard Bailly, which asked one of the questions here on November 27, same time. Thank you so much. And thank you all, the technical staff, Carlos, Victor, and Leonardo, and Gustavo for help me with the answers, of the question and answers part. Thank you so much. See you later on. Thank you, Sam.
Thank you. Yeah. Okay.
I'll cut the translation. Okay, I stopped the YouTube transmission. Thank you so much, Sam.
Yeah, no,